Hello all. Today is the review class. Friday we have midterm exam, so I'm trying to solve a bunch of the questions today to review chapter 1, 2, and 3. I may not have time to solve question for chapter 7, but since you're working on your on assignment and the deadline is tonight, so you may just remember that chapter. I already solved much of question for this chapter. But let's review chapter 1 through to 3. The exam is for the questions are from chapter 1 through 3 and 7. Totally 8 questions. And 4 short answer question and 4 long answer. The time for this exam is 2.5 hours plus 10 minutes for time for scanning and submitting your answer. That's just additional time to make sure that everyone can do it. So you have only two or three items to submit your exam. If you found that that's not a good quality or made a mistake in name, so you have another attempt to do that, but only the last one would be great. Okay, so the first question is from chapter 1. Is about viscosity and shear stress. So you will see a shaft here and bearing, and the shaft is it has a rotation here, and because of the gap that you have here between bearing and shaft, you will see that you have a oil, or which is your lubricant system, lubricant. And then because of the lubricant, you will have a toe shearing stress that gives you the shear force, okay? Which is that moves in this way because of the P force. Then you will have the whole shearing stress all over this area, which is half meter. The gap is given. So first, as I told you before, the most important thing so let me first write the two constant number here. First, density of water at 4 degrees is 1000 kilogram per meter cube, and nu of the oil is 8 times 10 to the power -4, because it mentioned that kinematic viscosity is given. I forgot to write it down there. Okay, so these two constants are given. So what's next? At first, as I told you before, even though that the question didn't ask you, you have to write a force type diagram. Okay, so first force body diagram, you need to show the shaft. Then first you have a P here, which is your force, external force that's applied. And then you know that this is D, the diameter, and that's your L. What else? You have a P here, but you have tau, f of tau. Tau is shearing stress, but this is force by diagram, So it should be F because that's the force. And you have to find the force. So what else you know here? You know the gap here. Even though that all these are given in the questions, remember to first make it like a parametric solution. Find the parametric solution, and at the end, you can replace those by the numbers, right? So give all the parameters that are needed for your solution character. Like B is not given in this question. Just mention that is the the gap is given. So I wrote it down as B because that would be easier for me to solve that based on the parameters, right? Like finding the equation, and then finally after that, instead of working with the numbers, I'll work with the parameter. That would be much easier for me at least. And what else is given, mentioned that assume the velocity distribution is linear. So it means that if you have this gap, which is B, then that would be your velocity profile, which is linear. Okay. So till now we wrote down everything. After force by diagram, you need to show that sigma F is equal to 0 at x direction. What else you should know? What is your directions? Okay, so sigma if equal to 0 in x direction, it means that f tau, which is negative, because in negative direction, should be equal plus p should be equal to 0. Then you will find that the p is f of tau. Okay, so f of tau is tau times area. And the area is where the cylinder is the surrounding area. So A should be pi dl, right? D times pi is the perimeter of the cross section times L gives you the area. What is tau? Is mu du over dy. Okay. What is du over dy? Because it's linear, is v velocity over b, the gap. Okay, so let's combine all to it. Write down that p, replace this over that, and replace this one over tau and area here. So p is going to be mu v over b pi dl. Okay, so you made it perfect. But what is this mu? Mu is mu of the lubricant, right? I will write it oil. Mu is mu of the oil, okay? But it is not given. What should I do? I know that the nu of the oil is given. So also rho of water is given. And Sg of the oil is also given. So if I write down that mu oil is rho of the oil times nu of the oil, right? Mu of the oil over times the density times the nu. And also I can say that the rho of the oil is Sg of the oil times rho of water, right? So if I replace all in the equation, then I can write down here that P is mu oil, that is here, but it can replace by Sg of the oil, rho of water, nu of the oil, times V, P, times pi, times D, and times R. And let's replace those. Sg is given in the question. Specific gravity is 0.91. 0.91 without unit is 4Sg. Times the rho of the oil is given is 10 to the power of 3 kilogram per meter cube. Times the rho times nu of the oil, which is also given here. It's 8 times 10 to the power of -4 meter square over second, the unit, times V of the shaft, velocity of the shaft also given 3 meter per second, 3 meter per second, and also B is given, the gap is 0.3 millimeter, or 3 times -4, 10 to the power of -4 meter. Okay, times pi, 3.14. D, the diameter of the shaft, is also given. It's 25 millimeter. So 2.5 times 10 to the power of -2. In terms of meter, times L, which is length of the shaft, and it's half meter. The answer will be, for P is going to be 286 Newton. And let's check the units. No unit, kilogram per meter cube times meter square over second times meter per second times 1 over meter for this, times meter and times meter. 1, 2, 3 meter plus 2, 5. I may made a mistake. So 1, 2 meter per second, 1 over meter. Oh, it shouldn't be cancel out totally. Okay, so 1, 2, these two are going to cancel out. This one going to cancel out, and kilogram meter per second is your newtons, right? Per second square. So the unit is going to be kilogram meter over second square, which is the newton. Any question?
I have one question.
Yep.
So why for the area did you do pi times the diameter times the length?
Okay. So if you want to find the area, because you know that, do you have any problem with this part? That F tau is tau shear stress times the area. Because shear stress is type of pressure, and pressure times area give you force, right?
Yeah.
Do you have any problem with that?
No.
Okay, so first you have to know that where is the area that tau is happened right? So if that's a circular shape, then whenever that you have gap B, you will have top, okay? So in all over this surface, that the bearing is all like a circular shape, you will have.
Oh, okay, okay, that makes a lot more sense. Thank you.
Right? You're welcome.
It's circumference
So-
times length, dude.
What?
If you think of it, if he thinks of it as circumference times length, makes it a little bit easier to think about.
Yeah, that's also true. But again, you have to a little know what is the shaft and bearing. So if you couldn't find meaning from the figure, then you will see that again, if you consider that is only like the shape is like this, okay? So this is not all over the cylinder. Then only in one line, because that's a circular shape. So in top, in side view, you will have this, right? So then you only have one part or one line that the distance is going to be B. The rest of that is not. And also in bottom, you will have the same, only one side, right? So it doesn't make sense to find tau B here. Why? Because you have to find tau times area, and area of the line is 0. Absolutely, you will have it, but that would be a hard question because you cannot find, you have to do the integral form and find it. So that's not that much hard. It would be possible to solve it, but not for this level that you are in undergrad level, because the mathematics behind that would be hard. And also the question should give you that what is the, okay, even though that the bearing is like this, it told you that the whole side from here that you have bearing, the whole part is linear and the gap assumed to be B, right? Because these are very close, or the shaft diameter is not that much. So again, here and here. And what you should do, you have to find that this is the gap, okay? And all over that times area. So area of a half of area is here, half of the area is here. Again, is the surrounding area. Make sense?
Yeah, it makes sense. Thank you.
Okay. So that was the question for chapter 1. And this relation between the, again, force by diagram is required, even though that you don't have directly mentioned in the question. So that's the second question from chapter 2, manometer plus for the pressure, static pressure, mostly for the flows, the fluid that are at rest. So what you have here, you have a piston that there is a pressure on top. That's the force. Okay, so I don't like that. This book wrote force with P because that's going to be a little mixed with the pressure. So that's the force, and the unit is Newton. Okay, so you have a force on top, and since that's the it compressed here, then you have a different pressure here, right? And the pressure of this point is measured by the manometer here, and the mercury that you have in this manometer, right? So you will find the pressure here, and then you have two forces, one in bottom because of the pressure and one because of the additional or external force that you have on top. And you have also the weight of the piston, but it's mentioned that is negligible, okay? So when you have forces, you need force by diagram. Okay, so force by diagram. That's my system, right? So what forces you have? First, you have a pressure, the force of P additional on top. And also you have P atmosphere here, which can be timed. If you time the times area, you will have this force as well, right? So what you have done, you have a pressure at point. I will wrote that this is your A and that's your B. Okay, so you have a pressure, it's a total pressure or absolute pressure at bottom. Okay, so summation of these should be 0, but you know that the P of the absolute means P absolute means P of the gauge at point A plus atmospheric pressure, right? So if I separate these two forces, what will we will have? You have two forces here. You have two forces here. One for the P of the gauge at point A and one from atmospheric pressure, right? So both of them should be multiplied by the area, correct? If you multiply those by area, then you see that these two forces are going to cancel out each other, right? So these two are, doesn't matter, because the atmospheric pressure that you have on top, you will have here, and this is going to be shows up here. Then these two are going to be canceled, right? So with this part, again, you need to show your directions and your reference points. So first, let's write the sigma of the y in y direction should be 0. Then the P on top should be equal to the P of the gauge pressure at point A times area. That's the area for piston area. So instead of area, I'll make it AP. Again, I will not replace the numbers, as since I know what is the area here is 0.07 meter square, but I will not replace right now. Okay, so what should, that's also given, but this is not, right? So you have to find using the mercury and using the manometer that you have. Okay, so let's start. If that's my point A and you have the P gauge at point A, then you can move from this point to point B and find the gauge pressure at point A, right? Using the manometer method, right? So in this manometer, you have to come down first to escape, right? If you use the escape method, then you'll use that in summarized form. So I'll come down from point A to here. So I'm going down, you need to add plus and come of water times H1, right? Because I'm going down. Then from here to here, I can jump because it's going down and then I'm going up, right? These two are the same. If you're going down and comes back here, then you will have the same pressure here because nothing changed. The fluid doesn't change. Again, you're going up, then going here, then coming down. Again, the same pressure here, right? If you have two fluids in the intersection of these two fluids, you have the same pressure, right? Because this is at rest and that's steady state situation, right? These are going to equilibrium. state. Then the flow pressure here is the same as pressure here. And also, again, you will coming down and going back here, and you will see you can jump here because the pressure is the same. Okay, so you are here now, and you are going to escape. Escape to point B means the pressure of the B, which is 0, because you are talking about the gauge pressure right now. And here, if you have atmospheric pressure, and atmospheric pressure, when you have atmospheric pressure, the gauge pressure at atmospheric pressure is 0. Okay, so what should we do? Should going up minus, and how much is going to be gamma of mercury times H. Then finally minus PB, which is 0, equal to 0. Okay, so you did. I need to add two given numbers here. Gamma of mercury is 133 kilonewton per meter cube, and gamma of water is 9.8 kilonewton per meter cube. So I just need to replace, clear that, but again, it's going to be 0. I don't want to rewrite it again. Okay, so I will replace, then let's find the P gauge at point A, which is gamma of mercury times H minus gamma of water times H1, right? If that's my equation 2 and this one equation 1, then I can replace 1 in 2 or 2 in 1 and find P, right? Then P is going to be area of the piston times gamma of mercury times H minus gamma of water times H1. Perfect. You'll find the answer based on the parameters that all are given, right? Only need to replace. Now it's time for replacing. So the P is 0.07 meter square times that's the area. Gamma mercury is 133 kilonewton per meter cube times H, which is 100 millimeter, given here, and the H1 is 60. So 100 millimeters is 0.1 meter. Minus gamma water, which is 9.8 kilonewton per meter cube, times 60 millimeter, which is 0.06 meter. Okay. The final answer for that, final answer for P is 889 Newton. And if we check the units, meter cube times kilonewton per meter cube times meter, right? Then these are going to all cancel out for the first term. And you know that's the dimensional homogeneity. So this one times the second one also should give you the same unit if you multiply that in. So again, you have kilonewton times meter cube times meter, and also you have meter squared back there. Again, give you kilonewton, and we multiply that by thousands. Then the answer is 889 or 8.8889 kilonewton. This is also true. This is very important to know that. Again, if you have a term with the unit 1 equal to term 2 with unit 2 times term 3 with unit 3. Then you can say that this is my unit 4. I can merge those, and the homogeneity of the unit shows that unit 1 is equal to unit 4, right? But if you have the term 1, which is equal to term 2 plus term 3, then unit of term 1 should be equal to unit of term 2, and also unit for term 1 should be equal to unit term 3, right? You cannot sum up the units here because both of them should be the same units when you can sum up all these two, and then should be equal to 1 because that's the homogeneity of dimensionality homogeneity in fluid mechanics equation. Any question? Perfect. So that's the question for chapter 2. Please review that chapter. That wouldn't be hard for you to solve the questions in the exam. Okay. That's a little challenging question, so we need more time to solve this, right? That's for chapter 3. But again, you know that this is from chapter 3 because I'm telling you, okay? But most of the time you have a question. This is going to be from all the books, right? Then on that time, you are not guided by the question or by me to know that which chapter is related to this question and which assumptions you have to assume for that. And which equation should you apply? That would be a little hard. So right now, your mind or mindset is constrained because you know that's from chapter 3, okay? But most of the time, the question in fluid mechanics should use most different assumptions, and the combination of all these chapters, especially chapter 4 and 5, that are the control volume and control surface, we already talked about that, okay? So remember that it's going to be easy if you know which assumption you have to assume. And but again, in real world, you are engineer, you don't know which assumptions are valid, right? And you have to try, or you have to use your experience, or ask the experienced guy. The question is very short. Water flows steadily, just steady, it's mentioned here, through the large tank. So it comes from here and over this large tank, comes down to below, okay? From this line coming to this line and coming up. So what it asks, what is HA? That's the question, okay? So what you need first, you need to put some numbers here, okay? I will write down that here is my point 1. Here is my point 2. This is my point 3. And that's my point 4. From point 2 to point 3, we have a difference. Here, the fluid is at rest because the tank is large, and this is the surface area, the surface of the flow, right? The fluid in the tank, which is a constant. The velocity is 0, right? Because this is a large tank, the flow comes out, and here the fluid has a velocity and you have a flow, but here you don't, okay? So, I'm sorry, here. But here again, is going to be the surface of that, and here, which is your point 0, you will have flow, okay? If you assume that this is a that's a steady, right? In a steady state situation, the path line of a particle and also the streamlines are matched, right? So you can write down from a particle, like say that you have a stone and put it the stone here, right? It comes down, it's going out, come here and going out, right? That would be a streamline for this whole shape, right? What else? If I assume that I have a control volume here, that's my first control volume. And also I have another control volume here, which is my second control volume. We know that in each of those, the Q that comes in, because that's a conservation of mass, right? The Q that comes in and the Q that goes out should be equal, right? So I can write down that in the control volume 1, the Q at point 0, which is or Q, is equal to Q in is equal to Q out. Okay, then I can write down that Q of point uh, 2. So here is Q2 and that's of Q, right? In control volume 2 is also, I can write down that the Q2 is equal to Q4, right? Because Q in and Q out should be equal. Then Q2 is equal to Q4. If I use these two, then I can say that Q2 is equal to Q4, right? So using this and also equal to Q. So it means that the flow that passes here, the same Q you have here, you have here, right? That's the first part, and keep that as first equation. Okay, what else? You have the areas here, right? You have area 1, area 2, and area 3 because you have the diameter. You can replace that. A2 times V2 is equal to A4 times V4. That's also equation that you find here. Okay. Why we need this equation? I'll let you know later when I apply the Bernoulli's equation. That the number of equations that you have is less than the number of unknowns that you have here. Then you need one more equation, which is the conservation of mass. Okay, so let's apply Bernoulli from point 1 to point 2. From point 1 to point 2, these two are over the streamlines. The flow is steady, and water most of the time in most of the equations are incompressible, and you are applying that over a streamline. What else? Inviscid flow, right? We can also assume that it's inviscid, but there is not any. If you see, you don't have anything that you have losses here. Okay, as long as you don't mention that you have losses, you can assume that it's not is inviscid. You can assume that, and you can apply that. Perfect. Okay, so what I can say, I can write then that P1 over gamma, which is all our gamma of what, right? So P1 plus V1 squared over 2G plus Z1 is equal to P2 over gamma plus V2 squared over 2G plus Z2, right? So that's the first equation. What else? I can apply Bernoulli from point 3 to point 4. Why I'm not applying that from point 2 to point 4? Because if I apply point 2 to point 4, then these two equations are dependent. Why? Because I have P1, which is equal to P2, and P2 equal to P4. Then I can cancel out all these terms that are from P2. Actually, I'm writing P1 to P4, right? So what's the difference between why I'm not applying from 1 to 4 and 1 to 2, and what is the difference between 2, 4 and 3, 1? The difference is this V. Velocity at point 1 and point 3 are 0, right? Because the fluid is at rest, but this here and 2, you have velocity. That's why I start from, these are on the same streamline, but here is at rest, but here has a velocity. So apply it between these 2 points, it's going to give you a different equation with applying between 3 and 4. But if you apply from 1 to point 2 and 1 to point 4, then since the Q are the same, the velocity is going to be related. And also the Bernoullis are not going to give you a different equation. Okay, so that's easier to apply from 2 different points in the same line. And if you find that okay, apply that from point 1 to 2 and then 1 to 4, and yeah, I find finally that these two are dependent, right? Then you are going to find a system of equations to solve the unknowns, right? What are the unknowns here? The velocities are unknown because it doesn't give you any velocity, right? You know that you have two velocity, V2 and V4, that are unknown. You don't have the Q, so you cannot find it. Only you have diameter of that. And what else is unknown? You have HA that the equation asks you. So you already know that 3 unknowns are here in the Bernoulli's equation, right? So you need 3 independent equation to make a system of equation, 3 equation, 3 unknown and solve, right? So if you by mistake decide to write the Bernoulli between 2 different points, then don't worry, you can come back and check it back and say that, okay, I want another independent equation that is between these points because I'm going to solve it. So I wrote it between these two because of that reason. So I will write it down between point 4 and point 3. Okay. So I know one very important thing here, that all the pressures are atmospheric pressure, because here, 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 and all points, you have the same pressure, right? Which is the static pressure is the same, is atmospheric pressure. So I can cancel out all these. Why? Because P1 equal to P2 equal to P3 equal to P4 and is equal to P atmospheric, right? So I wrote it down and cancel out that. What else I know? That the point 1 and point 3, the fluid is at rest, right? So if this point, the fluid is at rest, then I can say that this is 0 and point 3 is also 0, right? Okay. So the only thing I'm going to do is, since I have 0, 0, 0, 0 here, then I will bring it the Z in the other side, right? And rewrite the equation, okay? So if I rewrite these equations, I have equation 2, which is here is V2 squared over 2G plus Z2 minus Z1, okay, equal to 0. And I can replace Z2 minus Z1 as HA. Doesn't matter where you are going to put it, this reference number. I will put the reference number here, that then Z2 is negative, right? So Z2 minus Z1 Okay, so I will put it here. That's the difference. The difference of these two are HA, right? So you will decide that where I can put my reference point to define the other point, right? If I put it down there, then this is going to be, if I put it down there, then Z at point A is HA, right? And Z2 is 0, right? Okay, so then I can write down here that this is going to be minus HA, correct? Because I put the reference number down, then this is going to be HA, and this is going to be 0. 0 minus HA is minus HA. Then I can find V2 is equal to 2G times HA squared. Why I bring it down here is positive times 2J and square root of that, right? The same for the other question. What's that? Is V4 squared over 2G plus Z4 minus Z3 equal to 0. I'm putting my Z's here, okay? And then this is going to be HB, right? And here going to be 0. Okay, so this is going to be 0 minus HB equal to 0, and V4 is equal to the same, 2GHB. So what will happen if you decide to assume your Z a different point, right? Nothing gonna happen, okay? If you put again Z here, then this is Z2 is going to be minus HA, and Z1 is 0. And here, Z2 is minus HA, and Z1 is 0. So minus HA would be the answer here coming the other side, and again, the same answer happens, right? So nothing going to change when you even assume your reference point different, because these are independent of the reference point. That's why that you are deciding that where you have to put your reference point. Just because you find that the final answer easy, it doesn't change anything. That, hey, the reference point, if I put the reference point in another point, then the answer is going to change. It's not like that. That's why even if you decide to put somewhere else, it's not that much important. Again, you will have the correct one. Okay. So these are question 2 and 3, and also I had another question 1. So let's see here. If I forgot to do that, defining the control volume and equalize the Qs, what will happen in these two equations? I'm going to find HA, right? I have two equations. What I know that 2Gs are equal, or 2Gs are a constant number. HP is given. HA is unknown, one unknown, V2 are unknown, and V4 is unknown, right? 1, 2, 3 unknowns and 2 equations. If you decided to start with binary, then here you will start that. I cannot solve it. Why? Because I'm going to somehow find this. So I have to find the relation between V2 and V4 to give me another independent equation, and then solve the complex, the system of equation, right? Again, here you can write it down, the Q's and conservation of mass, and find this equation, which is your equation 1, okay? Because A2 and A4 are constant numbers and given the diameter, based on the diameter. So you can find the relation between V2 and V4. Again, if you find that this equation gives you 2 more unknowns, for example, the D's are not given, right? So this is not the equation that can use, because adding one more equation, that would be a closure problem. If you add more equation and it gives you more unknowns, then nothing going to change, right? You will have 3 equations, again 4 unknowns, and you will add another equation that has unknown by itself, then one equation added, at the same time one unknown is added. You need to find an equation or other equation that has the same unknowns in your two equations, V2 and V4, right? That's the, and also be independent. It shouldn't be, for example, V2 squared is equal to 2GHA is not another equation. You would only square each side. This is not independent equation. You need an independent equation. Okay, so if I replace that, V2 and V4, with the answer, right, with the answer that I have in I, what I can do, I can say that V2 times A2 is equal to V2 times V4 times A4, right? That's equation from equation 1. Okay, so, and also I can write that the A2 is pi D2 squared over 4, right? That's the area of cross-section area of outlet. The diameter is D, so the area would be pi D squared over 4. And also here is pi D4 squared over 4, right? What about V2 and V4? I can replace with these two terms, right? I will combine all together, right? And finally, if I replace these two, I will have pi D2 squared over D4 over 4 times V2, which is 2GHA. On the other side, I have pi D4 squared over 4 times 2GHB. Okay, so I will first, I can cancel it. Okay, and each side to the power of 2. Okay, so a to the power of 2, each side to the power of 2 is going to give you the 2 to the power of 2 times 2GHB or HA. HA, right, is equal to D4 to the power of 4 times 2GHB, correct? Again, I can cancel out 2G here, and the final equation would be, we'll write it down here, that H that HA, that's something you are going to find here, is equal to D4 over D2 to the power of 4 times HP. And HP is given. Now is the time for replacing. So HA is going to be equal to D4, which is 0.05 over 0.03 to the power of 4 times HP, which is 2, and give you that HA is 15.4 meters. Take a look at that in the whole, and let me know if you have any questions. Any question? Okay, so That's it. I reviewed chapter 1 through 3 and chapter 7 also. You have already working on the homework. I will upload, the deadline is tonight. And the additional extended time for those that going to penalty or 10% off are their homework going to be tomorrow night. But I'll suggest you to submit that by tonight and keep tomorrow. I will do my best to release the solutions by tomorrow night, and then you will have time to review the answer sheet and check it your problem, right? And also I solved 2 questions during the for the as a recitation during the teaching, and you will have that as well. Don't worry about it. If you review all, you will answer the question for chapter 7. You have 4 long questions that mostly are 1 from each chapter, or yeah, I guess. And that's it. So I will be today available during office hours if you have any question. And see you. We don't have any class on Friday morning, and see you Friday during the exam. I'll send an email and give you the rules and the policy of the exam, what is the links, and that's it. If you don't have any question, you comment. Have a good day, guys.
Hey, Professor.